welcome to Polynomial Division. We're going to take a closer look at how we can divide polynomials. We've seen how to multiply them, add them, subtract them, but now we're going to focus on division. So in order to focus on that, I would like to throw it back to the Stone Age. Yes, back in the days where we had a little bit of long division. Yes, it's been quite a while since we've seen some of these, so it's always a good way to remember how to do this. So the way this works, we would always see, okay, how many times does 6 go into the first digit? Well, it doesn't go into 1. It does go into 12 2 times, because 12 divided by 6 would give me 2. And then we would do what we normally do and multiply back down. And when we got to here, we would say, okay, now I'm going to focus on what's next. And we would subtract, and you would start to see some things begin to cancel out. So these would cancel out, and we would drop the next digit or the next term. I like to say term because that's going to help us coming up. And we would have a 0. And we repeated our process. 6 goes into 0. 0 times, multiply back down, and subtract. So you can kind of see I'm trying to keep these steps a little bit organized for us. And then I would drop the final digit, because 0 minus 0 is still 0, and I would have a 9, and repeat the process. 6 goes into 9. One time, it doesn't go perfectly into 9. And then multiply back down again. 1 times 6 is 6. We'll subtract, and this one we actually have something left over. We have a 3. So anytime we have a 3 left over, you would see it written a couple ways. Sometimes we would see 201 R3, which doesn't really make much sense. So the other way that we would write this is 201, and we would say 3 out of 6. And if you'd like to simplify that further, you definitely can. So let's use this exact same idea with, I'm sure you're feeling like Fred, with polynomials, because it does actually work the same way. And you're going to set it up just like long division. And what I'm going to do is rewrite the first term of what I am dividing by, my divisor, in a different color, because you're only going to focus on the first term. How many times can x go into 4x squared? Just like when we did 6 going into 12. Well, this would go in 4x times. And what did we do with the long division? Well, we multiplied 2 times 6. So you're going to do the same thing here. We're going to multiply. The tricky thing is there's this piece and there is this piece. So you are going to have to multiply 2 different times to get a 4x squared and then minus 4x, okay? And then what did we do with the long division? Then we subtracted them. There's that red minus sign. So we're going to do the same thing here. We're going to subtract, and it is this whole entire piece. So you can start to see where long division can get a little hairy. So we just got to go slow. 4x squared minus 4x squared. Those are going to cancel out. I've got negative 5, plus 4. So that's going to give me negative x, and just like before, drop the next term. And we're going to repeat our process. How many times does x go into negative x? Well, that's going to go in negative 1 times and multiply back down. Okay, that's interesting. Just don't forget, every single time you do subtract with long division. But hopefully you see something really nice, because I've got negative x plus x, so these are going to cancel, and then I've got positive 1, minus 1, these are going to cancel, and voila, you have a remainder of 0. There is nothing left over. Now, these are very special numbers, because let's say I do 48 divided by 4, okay? So the way that we describe that is we would say that 12 is a factor of 48. It is part of that piece. And you can do the same thing here with polynomials. Remember factoring? Why, yes. So that x minus 1 piece is actually a factor of that polynomial. And if you actually tried to factor, you would see that it works out because here's x minus 1. It's one of the factors. And oh, look at that. Here's the answer that we got. So let's try this one. So on this one, again, I would rewrite as long division. And I'm going to kind of walk you through how I did this one. So on here, you repeat those process. Well, if I take an x away, I have x squared left over. So it goes in x squared times, and then we repeat that process. And again, remember how you multiply back down. So x squared times x cubed, negative 1 times x squared is negative x squared. You subtract that whole piece, so you'll start to see x cubed minus x cubed cancels out. Oh, negative x squared plus x squared, both pieces canceled out. Well, that's fine. I'm just going to bring down the next 2. So now I've got x goes into negative 2x, negative 2 times. Same thing, multiply back down. Negative 2 times x, negative 2x. Negative 1 times negative 2 is positive 2, and then you subtract those pieces. So again, these cancel out. Negative 8 minus 2 is negative 10. This one has a remainder. So this is your final answer or your quotient. I'm just going to kind of keep repeating that word because it's a really helpful vocabulary word so you know which piece I'm talking about. So that piece is always called the quotient. So here's a question. Is there a way I can check my answer? How do I know I got the right answer? Well, let's think about that. If I'm dividing, how could I put this back together to check it? Why, I could just multiply these two pieces. I can multiply this times this and see if I can get back to the beginning. The only tricky thing is, don't forget, you do have an extra remainder. So after you've multiplied it out, tack on the remainder. And oh, look at that. Yes, we got back to the beginning. So yes, you can always check your answers with these. Okay, x goes into 4x to the 4th. These are getting crazy. Well, if I take an x away, I'm going to have 4x cubed left over, and then you got it. Multiply back down. So here's a 4x to the 4th, which is a good sign, minus 4x cubed. Again, this whole entire piece is getting subtracted because that's how we do long division. And then hopefully, watch out, I like to highlight here, 4x to the 4th minus 4x to the 4th, x cubed plus 4x cubed is going to give me 5x cubed. Drop your next term, so minus x squared. Same thing, let's repeat those process. How many times does x go into 5x cubed? Well, that's going to go in 5x squared. You'll kind of see you start to go down 3, 2. It kind of is a really good way to see if you're on the right track. Whole piece gets subtracted. Okay, I'm going to draw my next line. Start to cancel stuff out. 5x cubed minus 5x cubed goes away. Negative x squared plus 5x squared is positive 4x squared. Drop the next piece, so minus 5x. Keep going. Next one, how many times does x go into 4x squared? Well, that's positive 4x. Makes sense. 3, 2, 1. I'm slowly working my way down. Same thing. Go ahead and distribute. So 4x squared minus 4x squared. And then I've got minus 5x, plus 4x. So that's going to be negative x. Let's drop that 1 on down, positive 1. Same thing, how many times does x go into negative x? Well, that's a minus 1 time. Multiply down. So here's negative x. Ooh, I see something so nice. It looks like I am going to have a remainder of 0, which is really, really nice. So here's our final answer, that quotient right there on top. Man, these take so much paper. Wouldn't it be nice if there was a shortcut to these kinds of problems? Well, I would like you to meet long division's best buddy, synthetic. And before we get to synthetic, I wanted to showcase something you saw in the past. Remember these pesky old systems? We took all these numbers in front, those coefficients, and we built a matrix. I had three. Oh, I had a placeholder. There was nothing there. I had a 1. Well, wouldn't you know, there is something called synthetic division. It is a way that we can divide artificially, and it just focuses on the coefficients of the polynomial. You'll see a couple differences. You'll see that I'm adding here instead. We'll talk about this k value, so stay tuned. And down here is going to be where our answer is, and there's a little bit of a remainder. But let's try that same example, that one that took us forever, but let's do it with synthetic division, okay? So I'm going to focus on the coefficients, the numbers in the front. So I'm going to have this box here, a big long line, and then I would always make this plus. I'm going to make it in different colors so I can see it. Let's grab the coefficients. So I've got 4 to the x to the 4th. Okay, the k value that you saw comes from here. I see an x minus 1 piece. So the way that synthetic works is you are actually going to set that piece to 0, and that number is what's going to go here. So in this case, positive 1. So I'm going to add 1 to both sides. You are always going to drop the first digit to get down to 4. And here's the fun thing. You get to go backwards. We get to multiply. So I get to do 4 times 1 to give me 4. And then I get to add. Repeat your steps. 5 times 1 is 5. Negative 1 plus 5 is positive 4. Keep repeating your steps. 4 times 1 is 4. Add them up. Here's negative 1 and multiply. Negative 1 times 1 is negative 1. Ooh, and I get a 0. Interesting. I'm getting a sense of deja vu. 4, 5, 4, negative 1. Where have I seen those numbers before? Oh, yeah. 4, 5, 4, negative 1. It's the exact same answer. What? Welcome to synthetic. So when you write your final answer, again, it's a 4th. I'm taking one of those x's away, so it's going to start off with 4x cubed plus 5x squared plus 4x minus 1. All done. Final answer. Okay, remember that piece that goes in that top corner is always the divisor, what you're dividing by. So I'm going to pull this to the side, set it equal to 0. All right, now I get to pull all of the coefficients. So I've got, okay, negative 3x to the 4th, positive 1x to the cubed, and oh, wait a minute. Someone is missing from the Brady Bunch family because I have a negative 3 with a 4th, positive 1 cubed. Wait a minute. X squared is missing. So just like when you did matrices, you're going to put a placeholder, a 0. There's no x squareds. Then there's a positive 4x and a 7. Okay, same thing like before. Always drop the first one. So here's negative 3 and multiply. Negative 3 times negative 1 is positive 3, and add. 1 plus 3 gives you 4. Multiply. 4 times negative 1 is negative 4. Always add. 0 minus 4 is negative 4. Multiply again. Negative 4 times negative 1 is positive 4. Add them up. 4 plus 4 gives you 8. I've got 8 times negative 1 is negative 8, leaving me with a negative 1 left over. I'm going to go ahead and draw that. Okay, this one's a little different because it looks like I have a 4th and I'm dividing it by x to the 1st. So I'm going to have negative 3x cubed. I'm going to have positive 4x squared. See how those placeholders were helpful? So I'm going to add that remainder is negative 1 all over again. What are you dividing by? X plus 1. Final answer is that quotient down below. Don't forget to add the remainder with it. Not too bad. Okay, let's take a look at synthetic a little carefully. So go ahead and try to divide using synthetic here. So it kind of looks something like that. Okay, not too bad. This one actually turned out to be a little nicer because I'm taking a cubed and dividing it by regular x. So you'll see I've got x squared for the start. Okay, that's pretty straightforward. I don't see any issues there. So try to go ahead and divide that same polynomial, but use long division instead. Compare your answers. All right, so if I tried to do long division, I would see that 2x goes into, wait a minute, 4x cubed, 2x squared times. Okay, that's already looking different. All right, let me multiply back down. So here's where I got my 4x cubed plus 8x squared. You can see I've subtracted my pieces. Okay, how many times does 2x go into, oh, negative 6x squared? Oh, that's negative 3x. That's weird. Okay, I'm going to multiply back down, and you can kind of see how I color code mine to help me keep track of where the pieces are. And for me, that's just something that I like to do. Here's the problem. If I compare these two answers, they almost look the same, except one has been divided by 2. So how do we know which is the right one? Why would 1 be divided by 2? Where have I divided by 2 here? Oh, right here. I took a 2 away before I did the synthetic. Oh, that's what makes synthetic a little harder, because I think we can easily see that the long division is the correct answer, because 2x goes into 4x cubed 2x squared times, not 4x squared. You can kind of see why that doesn't work. So big warning. Don't be a dum-dum, as Kazoo says. Warning, synthetic only works when you are dividing by x and a number. So if it's like x plus 10, that's okay. You can do x minus 5, and that is okay. But there cannot be anything next to x. That is so dangerous, and you can kind of see that it didn't work here. So that is my big warning for you. All right, we're going to close off with something like this. Looking at just the remainder. I don't care about the quotient. I don't even care about the answer. Miss Hawkins, you care about the remainder. Ah, I see x minus 2 on bottom. Oh, thank goodness I can use synthetic. All right, so piece goes into here. Remember, you add, you set it equal to 0, so a 2 is going to go up there. All right, I see a negative 1x cubed. I see a 1x squared, and there's no x piece. So put a placeholder there, positive 4. Let's repeat those process. Drop that first one down. All right, so I've got negative 1 and multiply. Keep going, keep going, keep going. Negative 2 times 2 is a negative 4. Oh, would you look at that? So pretty nice. All I care about is the remainder. Done. Remainder is 0. I mean, that's not too much work. Here's something interesting. Why don't you try plugging 2 back in for the original function? All right, I need to cube the 2 first, which is 8. That will give me negative 8. Watch out for PEMDAS, your rules and orders of operation. Plus 2 squared is 4, plus 4 again. Is it me? Look at that. I got the same answer. And Dino would like to welcome you to our closing concept called the Remainder of Theorem. You'll see that if I'm taking a polynomial and dividing it by x minus a number, let's say k, this one happened to be x minus 2, then the remainder is what I get when I evaluate that function. If I plug in that value, the remainder is what I get. And you can kind of see how that worked out really well here. So here's the remainder, and here's what happened when I plugged in. Oh man, find a value. So let's find some kind of number here where when I try to divide by x minus 5, I end up having a remainder of 0. Well, let's see if we can use this new idea, this remainder theorem. So that says I want to plug in, instead of x minus 5, I'm going to kind of do it like the last one. I'm going to add 5 to both sides. So what I'm going to do is plug in and evaluate at x equals 5. Because right now I'm looking for the remainder of 0. So this is what the remainder theorem is telling me. So I'm going to plug 5 in, and now I'm just going to try to solve for k. And it actually works out really nicely because I just end up getting negative 14. So you can see I plugged in 5 and I simplified my numbers. And then I just tried to combine some like terms and I solved for k. All right, and as you can see, if I check my answer using synthetic division, why, yes, I do in fact get a remainder of 0. If it helps, this is actually the function that you are dividing by. If you'd like to give yourself a little challenge, feel free to check it with long division. You're going to see all of these methods actually kind of work together, which is one of the best things about synthetic, is it's just another tool in our toolbox.